the room clean subsequently. So this is how a single room and an autonomous vacuum cleaner would ideally work. Now the scenario that we are enacting here is a vacuum cleaner world with two rooms. You can consider them as two labs of your college, okay, which are adjacent to each other. Okay, and this vacuum cleaner has only ability to move from one room to the other room or clean the dust in that particular room. Then we should think about it. अगर ऐसा कोई vacuum cleaner मुझे design करना है ना, as I told you, what is agent abstraction? It is an analysis and design tool. So first thing we do is we analyze. अगर ऐसा कोई world आपके पास है, so we start thinking about कि इस अगर तरह का vacuum cleaner मुझे design करना है, तो उसको या उसमें क्या-क्या functionality होनी चाहिए. Okay, the description is in front of you. Now the first and foremost thing is there has to be some way that the vacuum cleaner knows that there is a dust in the room. Now this has to be there. If the vacuum cleaner has to take a decision on cleaning the room or changing the room, so what is the decision sequence that it has? Either the vacuum cleaner decides to clean the current room or he decides to move to the other room. So there has to be some way that the vacuum cleaner knows that whichever room it is in, is it clean or is it having some dirt. So if it is having some dirt, the decision which is most appropriate in this scenario out of the two decisions would be to clean the room. And if there is no dust in this current room, the vacuum cleaner will jump to or go to, navigate to, whatever you want to say, to the other room, right? So this way, if the vacuum cleaner is behaving, then I can consider it to be a vacuum cleaner agent, which is intelligent one. Okay, now just see what they are saying on the slides. So percepts क्या हो सकते हैं? So percept में दो percepts मेरे पास हो सकते हैं. एक तो मेरा location, because without location, say suppose these rooms are adjacent, as I told you in your labs also, they're adjacent. So if you are in first lab and say lab A and you want to move to lab B, then you need to move towards this direction, right? And if you are in lab B and you want to move to lab A, then you need to move to this direction. So directional sense is given by this sensor, the location sensor. It can locate itself whether it is in room A or room B. Now, we are not thinking about how this will be implemented. There could be a button switch on the particular robot. If I slide that switch, that indicates the room, or there might be a camera mounted on this robo car that actually captures some corner in the lab or some label in the lab that indicates that you are in lab A. And then it realizes if I'm in lab A, I need to move to right to move to lab B. And when it reaches the lab B, again it looks at in that particular label corner, takes a snap and realizes that okay, I am now in lab B. I am done navigating from lab A to lab B. Okay, so that is the implementation part. But when I'm talking about agent abstraction, I don't think about those implementation detail, and that is the beauty of abstraction. Abstraction actually removes unnecessary gory details and lets you concentrate on the things that matter the most when you are currently doing the analysis and design of the agent's behavior. So I want to design the behavior, how this agent would work, what actions that this agent would be taking, so that it would be referred to as an intelligent agent. Okay, now in this given scenario that is in front of you, you see that agent is in room A and there is some dirt in room A. There is no agent in room B and there is dirt in room B. So now if you see, this is the sequence of actions that the agent is performing. Okay, left, right, suck, no op. Okay, then after this set of actions, what will be the environment state? So now environment for this agent vacuum cleaner is environment consisting of both the rooms, right? So suppose it is following these sequence of actions. So it moves to left. So if it is already in room A and it moves to left, it will remain in room A. Then it moves to right and it will come over here. Then it will suck. So this operation is actually clearing the dust. So there will not be now dust in this room. And then it is doing no op. That means it is staying back in this room. So what you will be saying about such sequence of operations or such sequence of actions? This sequence of actions will actually clear dirt in room B, but your room A will still be dirty because you did not, as a vacuum cleaner, check first if there was a dirt in room A. अगर वो चेक करते तो पहले उसको आप सक करते and then you would move to room B. Now here we are assuming that this sucking operation is a one-shot operation. So if I suck the dirt, that means I'm sucking the dirt in entire room, and now room is clean after that particular activity. It's an assumption, obviously. This is a stripped down version. This is not how the reality, in reality, these vacuum cleaners, autonomous vacuum cleaners would work, but we are assuming that for simplistic reason, this suck operation is going to be clearing out all the dust in the room. Now this suck operation will have some time limit, right? क्योंकि एक रूम में जब मैं वो छोटा रोबोट को नेविगेट करूंगा, वैक्यूम क्लीनर रोबोट को, तो उसको रूम के एक कोने से दूसरे कोने में सभी जगह से डर्ट उठाने के लिए, रूम को क्लीन करने के लिए कुछ समय लगेगा. So there will be some temporal meaning associated to these actions as well. Okay, but in the current representation, the current abstract level of looking at the problem, we are not thinking about the time sensitivity or time associated with actual action. We are saying that, okay, this will be the action, next this will be the action, next this will be the action. Okay, so now whatever we have written over here, this thing is referred to as an action sequence. Generally, when we are talking about an agent, we are interested in getting this action sequence based on the percept sequence. Percept sequence से एक action मिलेगा, नया percept आएगा, percept sequence update होगा, वो percept sequence input आएगा, एक और action मिलेगा. ऐसे जो मुझे action मिलेंगे, तो जब मेरा particular agent काम करेगा continuously in a continuous loop, it will keep on churning out one action after the other action, and this sequence or collection of actions I will term it as action sequence. So hope, I guess, now the idea of what exactly is an agent and how exactly an agent function works, what do you mean by agent program, is clear to you. So the agent program is going to run continuously to produce these actions in sequence like this. Okay, that is called as action sequence. So action sequence is the output of agent program being executed continuously, just like event loop. Okay, every time an event occurs, say suppose एक get event है, post event है, जब आप click करते हो कोई button, तो वो event होता है. There is a event handler. That event handler function will execute. Its output will be generated, and then you will come back to the listening for next event for to occur, right? So this is how an event cycle works. This is how the game loops work in game programming, and this is how the agent program also works. It is a continuous execution of same kind of steps. Okay, now let us go to the next slide and understand some more details about this vacuum cleaner world. Now, so this is some simple agent function. So what is the simplistic way of mapping the P star? So ultimately what we are looking for when we are looking for agent function, we are looking for this P star map to A. So I'm looking for this particular mapping when I'm creating this function. So function is like mapping your pre-image to image, right? Action is what is on this right hand side, and percept sequence is on left hand side. Now with just two tuple percept, so see, तो मैं percept को कैसे define किया, ऊपर ही define किया है उन्होंने. I'll just use the text box. So we are writing this way a single percept. Okay. So now how will we be writing percept sequence? ये एक सिंगल परसेप्ट है, ये जो है ये एक्चुअली टपल है, वो लिस्ट की तरह उन्होंने दिखाया है, बट इन जनरल those who are familiar with Python like programming language, this is your tuple, a single particular thing, single परसेप्ट। एक टाइम पे मेरे पास दो सिग्नल्स आ रहे हैं, एक तो मैं कौन से रूम में हूँ और क्या रूम क्लीन है या नहीं, ओके, एंड देर आर it's going to have two values. So there are four different kinds of combinations that I can receive, or that this particular tuple value can have. So A clean, B clean, A dirty, B dirty. So there are four combinations that I can have. Now whenever I say percept sequence as this property, so both of you, that is IT as well as computer students, they know what does a star indicates. Star indicates zero or more occurrences. So I just am going to append one of these four. Okay, A clean, B clean, A dirty, B dirty. A clean, B clean, A dirty, B dirty. One of these four, I'll be just keeping on adding to this particular list of percepts to generate a percept sequence. This is exactly what they are showing. Initially, when I am in room A and I find it to be clean, okay, so what should be the action that I should do? I should go to the right side. Then if I am there in room A and I feel that the room is dirty, or I get the sense that the room is dirty, then I should do this particular activity to suck the room. If I'm in room B, okay, and that is clean, then what should I do? I should turn back to the left room. Then B, and if I'm in B and it is dirty, I will suck the dirt out of it. Okay, so these all are first four different kinds of percepts that I can receive. So an agent can be in room A and see the room to be clean or dirty. Agent can be initially in room B and see the room being clean or dirty. Now what this particular entry in the table is, I'm in room A, I see it to be clean. Then next time I see myself again in room A and the particular thing is clean. Okay, तो ये A clean ऐसा दो बार मुझे दिखा, तो पहला A clean हो जाएगा, तो मुझे राइट या राइट एक्शन लेने के बजाय मैंने क्या किया होगा, I could have stayed there instead of actually moving to the right or clearing the dust. ठीक है, डस्ट नहीं है तो क्लीन करने की जरूरत नहीं है. I might have decided not to move right, and again after some time I must have received another sense that still I am in room A and the particular room is clean. Now this is a percept sequence of length 2. Okay, this is a percept sequence of length 2. Length 1 के 4 percept sequence थे, तो length 2 के कितने percept sequence रहेंगे? 16 combinations would be there, right? So if I am building my vacuum cleaner agent based on building of such a table and keeping track of such table inside my agent's question mark block. So question mark block, at minimum क्या करना था मुझे? At minimum मुझे P star को map करना था A के साथ, right? That was the thing that this function is going to do. Okay, so this is the simplest way of organizing all percept sequences in a table and then define a corresponding action to do for that kind of percept sequence. Now, this first thing, अगर ऐसा कुछ करना है तो ये कब करना पड़ेगा? Before you start operating, before you put this particular table inside. So ये table को realize कैसे करोगे? Like an if else kind of a rule. If this happens, do this. If this does not happen, do that. So that is how you will realize it as a program. Okay, but ultimately what it is something like a percept sequence mapped to action. So it's like a dictionary where the index of the dictionary is particular percept sequence, and the key in the dictionary, or the value in the key in the dictionary is particular percept sequence value, and the value in the dictionary is the action that you choose for that particular percept sequence. So ये percept sequence है, ये action करना है. Okay, I guess you have understood what this particular table is, and you have to create this table before you start operating, because once the table is ready, then only you can start operating, because you don't know what percept sequence you will receive, right? Again, saying so, this percept sequence, is it enumerable? That is, can I write all the set of percept sequences which are going to be there in this particular scenario? Probably not. Probably there would be infinite percept sequences, and that is exactly what is meant by writing these two dots over here. So this is not a feasible solution, although this is the simplistic solution that I can have, that is to pre-decide what to do as an action on a predefined percept sequence. अगर एक predefined percept sequence आया तो मेरा action क्या होगा. ये feasible नहीं है because I may not be able to list out all the types of percept sequences that I might receive as an agent. Okay, so this is what is a first kind of hit at how do I implement the agent program. Okay, now we'll go a bit to a sideline and try to understand what makes the agent the rational agent. Okay, मैं थोड़ा बहुत उसके बारे में पहले ही डिस्कस कर चुका हूँ, so it will not take a lot of time to discuss these two slides, but this is exactly where we talk about or we try to understand what makes an agent a rational agent. So what should I add as an ingredient in the architecture of agent so that while I'm modeling that mapping, I should also take care that the agent is a rational agent. Okay, so that is what the discussion of these two slides is going to tell us. The agent should strive to do the right thing. ये हमने देखा था, based on what it can perceive and the action it can perform. The right action is the one that will cause the agent to be most successful. It's सबसे important है. राइट एक्शन किस चीज को बोलोगे, तो ऐसा एक्शन जो आपको एज एन एजेंट मोस्ट सक्सेसफुल बनाएगा, that will be the right action. Now how do I know that I will be most successful? I need to have certain kind of utpatti or certain kind of measurement. Okay, how do I understand that I will be successful or not? There has to be some measurement, and that measurement is determined or that is defined as the performance measure. How good the performance of the agent is. This performance measure in a way is an objective criteria. Objective means you can test whether you have reached it or not. So it's an objective criteria. Subjective यानी वो आप describe कर सकते हो. Objective is which you can compare. You can identify or relate to and say I am better or worse than what was the particular performance measure. So it's an objective criteria for identifying success of an agent's behavior. Okay, so ये जो वैक्यूम क्लीनर वर्ल्ड था उसमें क्या ऑब्जेक्टिव क्राइटेरिया हो सकता है फॉर परफॉर्मेंस मेजर. एक तो हो सकता है कि मैं दिन में या गिवन पीरियड ऑफ टाइम में मैंने कितनी बार सकिंग ऑपरेशन किया. दैट मीन्स हाउ मच गुड आई एम एट क्लीनिंग द डर्ट. Okay, second objective criteria could be, since we are talking about an appliance that is doing things autonomously and that is able to navigate from one room to the other room and suck the dirt, it will have certain kind of electrical supply using some battery or using some sort of a socket. So whatever way it is getting the electricity supply, my objective could be to have minimum usage of electricity. So that could be my performance measurement. I'm not that much interested in how good it is at the cleaning, but I might be interested in how long it can clean. Okay, it depends on what place you're talking about. Okay, if you're talking about a railway station kind of a scenario, which is going to get dirty now and then, it should clean off the dirt, but at the same time, it should run through the entire operation cycle. अगर मेरे particular area में या मेरे particular location में, my railway station, there is a peak load or peak load of people turning on my railway station or railway platform from say 10 a.m. to 12 p.m. Okay, then during this entire period, my vacuum cleaner should keep on working. It should consume its battery so much so that it can only be charged after this time is over, and it should continuously operate. That can be then the performance measure. So performance measure is linked to where I am going to place my agent in. Now, if we are talking about an agent that is cleaning the dirt in a temple, we would like to have temple clean all the time. Okay, and there is no now concern about when people come to the temple, what is the rush hour. Okay, I can charge the robot maybe sometimes frequently, more frequently I can charge my robot, because generally temple has a single room or not multiple rooms, but there my objective criteria would be to keep it clean. So I will be more interested in amount of dirt that it sucks up or clears up during that period. Okay, again when we are talking about equipment, it might be actually making some noise, so another criteria could be amount of noise that it generates. Okay, since you are actually talking about the equipment that is running around here and there, and if there is a lot of people moving around, then there could be a criteria where people should not attack this particular machine, or this machine could not attack certain people. Attack means hit certain people. So there could be different ways in which I can organize what could be the performance measure. And also I can have multiple different objectives using which I should be defining the performance measure. It could be a combination also, it could be a trade-off also. Okay, so please understand this particular part. The performance measures role in the agent abstraction is to make agent an rational agent, because performance measure will provide it certain means to do the assessment of its behavior and decide upon what would be the best alternative. Because ultimately एक एजेंट रैशनल एजेंट होगा अगर वो करेक्ट एक्शन लेगा, और करेक्ट एक्शन कौन सा होगा? द करेक्ट एक्शन विल बी द एक्शन दैट makes the agent more successful. I hope this thing is now clear to you, where exactly this performance measure fits into the scheme of things. The sensors, actuators, they are part of the agent organization itself. Okay, sensors are providing the percept and ultimately the percept sequence. So that's the first ingredient of that mapping that we want to model. Okay, action provides you the right hand side domain of that mapping. मैपिंग कैसा है? पी स्टार का मैपिंग है ए के साथ. ए इज सेट ऑफ एक्शंस. Okay, so actions will, actuators would tell me what actions the agent can do, and now using those actions I can learn the right hand side of that mapping. So left hand side of the mapping will be determined by my sensors, because sensors will give me the percepts. Whenever I say that robot is having those two, that tuple as input every time it senses its room, say A, B and clean or dirty, these things are given to the agent through what? Through the sensors. So that's why when you are analyzing a scenario and identifying agent in that scenario, first and foremost thing you do is identify what are sensors, identify what are actuators, define what could be the actions, what could be the percept sequence. Okay, then next thing that we need to think of is what is the performance measure. What is the performance measure? Because the rational agent, agent will become a rational agent only if we have certain criteria using which I can assess my behavior. Now assessing the behavior can be a post-mortem type or a precautionary type. पोस्टमार्टम टाइप किया तो कंट्रोल थ्योरी हो जाएगा. प्रिकॉशनरी किया तो आप पहले डिसाइड करोगे बिफोर डिसाइडिंग द एक्शन which is the correct action. Generally rational agent are those agents which do precautionary assessment. So performance measure is going to tell me in advance अगर मैंने ये किया तो उसका नतीजा क्या होगा, उसका इफेक्ट क्या होगा, ये किया तो ये किया मतलब ये एक्शन किया, वो एक्शन किया, तीसरा एक्शन किया. So I have certain objective measurement through performance measure. You also learn that performance measure is connected to what? It is connected to the application where the agent is working. So environment in which the agent is working, for what purpose we are using the agent, depending on that we need to analyze and figure out and define the performance measure. Okay. Yeah, fixed performance measure evaluates environment sequence. 1 point per square cleanup in time t, 1 point per cleanup square per time step, minus 1 per move, penalized for greater than k dirty squares. So these are some ways in which they have defined performance measure. Okay, for the vacuum cleaner world. What the first one says is you give a +1 as a point एक पर्टिकुलर स्क्वायर इंच क्लीन करने के लिए. अगर आपने वो रूम को डिवाइड किया किसी डायमेंशन में, तो उस डायमेंशन से इतना क्लीन करोगे तो 1 पॉइंट मिलेगा, इतना क्लीन करोगे 1 पॉइंट मिलेगा. सो डिपेंडिंग ऑन दैट यू विल अर्न पॉइंट्स, एंड देन इट विल बी 1 पॉइंट पर क्लीन स्क्वायर पर टाइम स्टेप. सो यू हैव टू से दैट विद इन दिस पीरियड ऑफ टाइम आपने कितना क्लीन किया. सो यू आर गिविंग सम टाइम मेजरमेंट. So from these English description of performance measures, we are supposed to define some objective or numeric kind of performance measures that can be implemented inside the agent program. Okay, selection of performance measure is not always easy, and that is very important. That depends on the